dying, but not dead yet. But all right. Okay. First of all, we'll go over what's on the quiz. And I know some of you are just jumping into the quiz before I'm, talking about it, but that's all right. But okay, how would we go about doing this? Okay, it's been like a hot minute since we've had class, so plug this in for t, and then take the derivative of this, put it out front. So this would be 4x cubed cosine of x to the fourth. That's it. Okay. This one, what would be the area? Oh, did I not have that in? Oh, the graph of the function. Oh, I must have not put that in. What's the area what's the area from 0 to 7? If this was like that, what would it equal? -5. Okay. This one, what would you do on this one? Yeah, because the x goes in for every t, and then you put the 4 in for every x, and so it is 4 squared minus 4 over the square root of 4, which is 16 minus 4 over 2, which is 12 over 2, or 6. Okay. What is this function from 0 to 3? Well, you have 1 square, 2 squares. This one is 1, and this one is 1, so it's 4 total. Okay. What? Negative. Thank you, Liv, because it is negative because it's below the x-axis. Thanks for saving me. Yeah, I about did that really wrong. Okay, this one is a tricky one. It's just trying to trick you, Nate Ricky. Why is it trying to trick you? Why, Nate Ricky, why is this trying to trick you? No.
Positive.
No, but why? Why? Why?
Why is it positive?
Yeah.
I can't read the board. Sorry. Oh, now I can read it.
Why?
Because you're doing it backwards. You're going.
Yes! Who whispered that into your ear?
Oh, I knew that.
Okay, thanks, Allie. Okay, so when the number on the bottom is higher than the number on top, you're going backwards. So see, if you're going from 3 to 7, it'd be -3. So if you're going backwards, this really flips up to the top, and it's a +3. Okay? All right. This one. What's an appropriate calculus-based justification that G has a point of inflection at C? Is it because the function is 0 at that point, or because it has a relative maximum at that point? Relative maximum. You guys are so smart. It is a relative maximum. All right. And then for this function, what's G of -1? Well, you put the -1 here in for x, right? Fundamental theorem calculus. Put the -1 in there. So -4 to -1, -4. Come on, Miss Bierschbach, draw to -1. So this area right here is 6 times 4 or 6 times 3, which is 18. And then this area right here is half of 2 by 2, which is half of 4, which is 2. And this is 2. So this is 22. Okay. So that's the quiz. Okay. That's what you'll do in the quiz. But since all of you take different times to take the quiz, I'm going to go on to what you're doing later today and what you're doing on Friday. So those of you taking the quiz right now, make sure you're paying attention. Okay? The fundamental theorem of calculus and definite integrals. A definite integral is super easy. It's easier than indefinite integrals. Okay? What you do is just plug the 7 into the function, plug the -1 into the function, and subtract. So 7 plus 3 is? 10 squared. -1 plus 3 is? 2 squared. So it's 100 minus 4, which is 96. Bada bing, bada boom. That's it. Okay? Okay? So then this one, you plug the 5 in, the negative 5 in. What's 4 times 5? 20 minus 20 is? 0. So it's the absolute value of 0 minus negative 5. 4 times negative 5 is? Negative 20. Minus 20 is? Negative 40. The absolute value of negative 40. 40. What's 0 minus 40? Okay, that one's a little messed up with the positives and negatives going back and forth all the time. Okay, this one, put a 12 in, you get square root of 36, which is 6. Put a 3 in, what do you get? 3. 6 minus 3 is? There you go. Yes, subtract them. Take the top minus the bottom. Okay, now this one. Okay, now we're to indefinite integrals. Indefinite integrals. So, an integral is the opposite of taking a derivative. Okay? So if you take a derivative of like 4x cubed minus 3x squared plus 5x minus 4, what are you going to get? 12x squared minus 6x plus 5. But what happens to this? It disappears. So when you're going the other way, then what is that? Well, we know that has to be a constant value. So we're going to put in a plus c, which you will see right here. It's some constant value that appears, and we're going to actually solve for the constant value here in the future. But for today, you just know that when you take an integral, which is an antiderivative, opposite of a derivative, you just add a c onto the end. Okay? So which matches to which? If you take the derivative, think, Mr. Bishop. If you take the derivative of this, which one in the right-hand column is that?
The middle one.
The middle one. So the middle one goes with that. If you take the derivative of this, where does it go?
Top one.
Top one. And the derivative of this is this. Okay? So you're just matching, so it's just taking derivatives, and then what we're going to do is actually, without matching, we're going to have to go this direction. Okay? Okay? So it's just a matching again. So this one would be which one? Middle. This one would be bottom, and this one would be top. Okay? Okay, here we go. Reverse power rule. This is now Friday's stuff. Okay, to do the reverse power rule, okay, what would make something y cubed? The derivative of what would make y squared, I should say. So, in derivatives, we drop the power by 1, right? So when we integrate, we add by 1. So it's y cubed. Well, what's the first derivative of y cubed? 3y squared, not y squared, right? So whatever you do with the power, you divide by that. So we can either put a 1/3 in the front or call it this. Either way, either one of these works. And that's what goes in. And then you go plus c at the end for now because it's just plus c, because plus some constant. Okay? So what if we have a fractional exponent? What's x to the 3/4 go to? X to the? If we add 4/4 to it, because we add 1, it's x to the 7/4. If we divide by 7/4, it's the same as multiplying by 4/7. What's 7/4 times 4/7? 1. So that's 1 x to the 3/4 if you take the derivative of that. So it's 4/7 x to the 7/4. Because if you take the derivative of this, you should end up with that. So integrating this goes to this. So it's derivatives in the opposite direction. How about a negative exponent? What's negative 5 plus 1? Negative 4. So we put a negative 1/4 out front. This times this makes 1, right? Okay. So it's negative 1/4 x to the negative 4th. Is that it? Okay. There will be a couple more things that you do on Friday. You'll just have to watch him. But that's the basics of what's going on Friday. So today, you got the quiz. Take your quiz, and then when you get done with that, you're doing definite integrals, and then just doing that matching thing for indefinite integrals. Go.